The idea behind tipping points with human forcing is that we make those sorts of things more likely to occur in unquantifiable ways, but it increases the risk.
And so in answer to one or two of my questions, they are real and you are concerned.
Absolutely. And I mean, this is, for me, another background reason why aggressive mitigation makes sense, because the less we poke the system, it doesn't eliminate the risk of abrupt changes in climate, but it certainly reduces them. And again, you're not going to be able to put a dollar value on it. You're not going to be able to predict when it's going to happen. This is one of those things where it's one of those benefits we get from aggressive mitigation is we're just provoking the system a little bit less.
Hello, I'm Michael Liebreich, and this is Cleaning Up. It has been a very big month in the world of climate science. The worst-case emissions scenario that's been at the beating heart of climate science for 15 years has been declared implausible. Yep, that's right. Hashtag RCP8.5 is dead. Regular listeners will know that RCP8.5 has been something of an obsession of mine. You might not have heard of it anywhere else, but I can guarantee that it's behind almost every news story you've ever read about what happens if we don't stop climate change. It is also, and always has been, wildly implausible. By the way, that's not to say we should not be very concerned about climate change and taking action urgently. Where we're headed is bad enough, but we're not tracking RCP 8.5. My guest today is an expert on the use and misuse of science in policy. He's one of the world's leading experts on the cost of disasters, an early and much-cited researcher into hurricane and tropical storm impacts. He's written several books on science and policy, including one on the need to transform our energy system to address climate risk, and one on the different roles science can adopt in informing policy. Until recently, he was a tenured professor at the University of Colorado at Boulder, and he's now senior fellow at the American Enterprise Institute. He also publishes an influential Substack called The Honest Broker. Professor Roger Pielke Jr. has been on the show before, in June 2022. If you want to know the background to the RCP 8.5 controversy and how the climate science community tried to silence him, you should listen to that episode. It's number 93, and there's a link in the show notes. So, to tell us about the seemingly wonky changes roiling the climate scenario space and what they might mean for all of us, please welcome Roger Pielke Jr. back to Cleaning Up. Roger, thank you so much for coming back on Cleaning Up.
It's great to be back. Good to see you.
So you're in London at the moment. What are you doing over in Europe? What's new?
So I'm on a trip. I went to a science policy conference in Austria, and I'm making a stop in London, meetings and discussions on my way back to the U.S. Things are good. I retired from the University of Colorado.
Well, that's right, because I've said in the introduction that you've been on the show before, and University of Colorado at Boulder, tenured professor. Everything's changed. How has it changed?
Yeah, everything's changed and nothing's changed. Institutionally, I affiliated with a think tank in Washington, D.C., American Enterprise Institute, which is an absolutely fantastic organization, much closer to policy and politics than being at a university. But in other respects, my day-to-day life is very much the same. Still doing research, still writing, still traveling, still speaking. So it's a different career phase doing similar work.
Now, in my world, you're famous for climate policy because you work at the interface between science and policy. And as I say, in my world, famous for your work on climate. Have you been doing much on sport and the other areas that you've done recently?
Yeah, I'm actually almost, I'll break some news, almost done with a book. It's called Defining Women, the battle over sex, science, and fairness in sport. And as everyone knows, the science of gender eligibility is hotly contested, and I've got a new book on that topic. So I've been doing a lot of work on science and politics and where they collide. Climate's probably the most visible and public facing, but there's a lot to work on these days.
I do feel that we owe the audience a very short version of the thesis of The Honest Broker, because you've got a Substack, The Honest Broker, and it's one of the few that I think I pay to subscribe to. So that should make you feel good, because I don't pay for many, but it is, in my view, a must subscribe. But the name The Honest Broker, which is also the name of your book, I don't know how many years ago, just give us the short version of the thesis, because I think it'll be important as we go through the conversation.
Yeah, so you're exactly right. The Substack is named after my book, and I just was contacted by a junior scholar who mentioned to me that next year is the 20th anniversary, which makes me feel old, but it's also nice that people are still talking about it. The basic idea is that experts need to discuss the role that they want to have in relation to the broader society, and we have choices. We can be advocates. We can just go into our ivory tower, shut the door. We can be honest brokers, which is providing a range of options to decision makers. Or we can participate in basically with science advisory processes, like the Intergovernmental Panel on Climate Change, IPCC. It's kind of an in-joke, the title of my Substack, because people think, well, the honest broker, you must be referring to yourself. And in my book, I'm very clear to say honest brokering is a group activity. It's something we do together. And so I very much view the Substack as an opportunity to create a community where we hash out issues, we talk, we disagree, we argue, and we do it in a respectful way.
Right. And I think it is incredibly germane to the conversation about climate science, because there are those who just say the scientists should just science away quietly in their ivory tower and let whatever happens. There are other people who say, no, the scientists have to be on the front line advocating for particular policies that will achieve outcomes that their science says are needed. And these are different roles within the sort of little matrix in your book. So again, it may be 20 years old, but I just think it is still a useful framework.
Yeah, I appreciate that. The framework's super simple. It's meant to start a conversation. All of the roles the book describes are really important to have in democratic governance systems. The important thing is that we experts have that discussion. How do we want to relate? One of the worst things that we experts can do is say, follow the science. Oh, and the science happens to be what I value, rather than engaging with the broader public and realizing that people have a diversity of values we have to reconcile.
So this is an incredibly current discussion, particularly in the US, where the president has passed is it a presidential? What are they called? Not a decree. We don't have those.
Executive orders.
Executive order, yeah. Restoring gold standard science, and then there's been this attempt to it's I guess it's an attempt until such time as it goes to the Supreme Court and whatever to reverse the endangerment finding. So, I mean, this is the scientists saying there is clearly a danger, and then the policy environment at the moment saying essentially in your box, and if not, we'll defund you and we'll get rid of you, we'll shut you up and shut you down. Is that a fair characterization of what was? I mean, is that fair? Is that what's happening? And then I suppose I should ask, how involved have you been in that conversation?
Yeah, I haven't been. I'm a commenter, and I'm not an insider, nor do I have any insights to the Trump administration. Let me say first, for your non-U.S. political science audience, which is probably most of them, executive orders are a way for the president to tell the bureaucracy, the executive branch, what to do. They're mostly for show. They're good for press releases. They will last about as long as the administration, because the next president can come in and rip them up or have their own. Lasting, durable policy in the U.S. goes through Congress. And so a lot of what the Trump administration has done gets a lot of attention, but it's not going to be lasting. The other thing is that the Trump administration doesn't have anything that we might call science policy or climate policy or any specific policy. It does have a campaign, I've called it this in writing, of vengeance. There is some intense anger among the MAGA Republicans against experts, the scientific community. In my hometown, Boulder, Colorado, the National Center for Atmospheric Research is targeted for elimination. They're probably going to cut it up and move it to different places around the country. But that's not the result of policy. That's the result of what's been reported, a political dispute between the governor of Colorado and Donald Trump. So there's less thinking behind those sort of policies than you might wish would be there.
You say that, but the Department of Energy, Secretary of Energy Chris Wright, kicked off very early on, one of the first things he did, kicked off this sort of alternative review, a kind of international intergovernmental panel on climate change, except that it was run by a few hand-selected folks. And they produced a view which was very, very different, which cited your research very, very extensively and was almost immediately withdrawn. What the hell's going on there?
Yeah. So first, let me say I know Chris Wright. He's a Colorado guy. He went to the wrong high school, but he's still a good guy. He knows an enormous amount about energy, and he would be a great Secretary of Energy under any president, Democrat or Republican. His instinct when he came in, apparently, and again, I don't have any inside information, was to try to balance out what he and the administration saw as one-sided assessments, particularly the U.S. National Climate Assessment, by impaneling a small group to cover, here's what's been missed. This goes under what has been called the red team versus blue team approach, which might make sense in military planning, which is where it comes from. It doesn't make sense for climate science. I never thought it was a good idea. They didn't follow all the procedural necessities under the U.S. government, got sued and was disbanded. As you say, our work was among the most cited. It's interesting. There was a lot of complaining and criticizing of the report they came up with. No one talked about our work, which was the most cited in the report.
And when you say our, can you just say who is our?
Well, they cited me and my colleagues' work on extreme events, floods, hurricanes, tornadoes, and climate scenarios, which we'll talk about today. So it's probably about a couple dozen people involved.
So these are co-authors on papers you've been involved
That's right.
in. It's not like some little secret cabal that tries to.
Well, we go by the name the Illuminati, and we no, no. Yes, it's just a group, and it's not a coherent group because the people I work with on extreme events are not the same people I work with on scenarios. It's just a lot of credit needs to be spread around. I get a lot of attention, but it's a group exercise.
So I think just to complete on Chris Wright, he is very smart and he does know energy inside out and backwards. What I would say though is two things. First, on his view of the transition, it's a very kind of fossil based. There's all this fossil energy. It's going to be impossible to replace because it's 80% fossil, which is the primary energy fallacy. And on climate, he cites William Nordhaus, and Nordhaus, Nobel Prize winner for inventing the IAMs, integrated assessment models, but his work shows that I think it's a 3 degrees or 3.5 degrees by the end of the century is not just the worst case, which we're going to get onto,
right.
but it's actually the optimal outcome. And of course, it would then continue to get warmer after that. So I would think it's fair to say, you'll know better than me, that in the climate science community, in robust climate science of today, he is very much viewed as an outsider if he still holds those views.
Yeah, I would say, those views are much more in energy systems modeling than straight up climate science. When Chris was the CEO of Liberty Energy, natural gas firm,
the fracking services provider.
For the last several years, I don't know how many years exactly, but they published a report called Bettering Human Lives. And the organization it cited most extensively was the IPCC. So my sense is that on climate science proper, he's pretty much in the mainstream. His views on energy, he knows a lot about energy systems, obviously having been in that industry. But he recently said something that I don't agree with. He said, for the rest of my life, coal is going to be the dominant energy source in the world. And, I would disagree. But the other thing is,
well, in the electricity system, renewables last year overtook coal. Not many people have kind of got to grips with that.
Right.
But in the electricity system, if you add hydro, wind, solar, and a few bits and pieces, geothermal, bio, but they're tiny, then you actually get coal no longer king coal, and it's going really, really fast. And I would argue that the situation currently in the Gulf is going to accelerate.
I think that's right.
He thinks all of these global South countries are just going to want the same as we had, coal and then oil, and then eventually they might sort of become woke and do this something else. That is not what's happening.
Well, and also, I mean, nuclear is having a moment also around the world. And so I do think that the prospects for rapidly expanding nuclear energy are much greater than they've been at any time in my career.
True, largely because there's some very, very rich people,
Right.
The 7 hyperscalers and so on, who need it badly for their business model, and they've got infinite money.
Right.
I think the jury is out on whether it can become affordable. But let's come on to the most exciting topic, the most exciting thing in the news, which is that the new hashtag, I used to have this hashtag, RCP8.5 is bollocks, and the new one is RCP8.5 is dead. So tell us what happened last month.
Yeah, and let me just say at the outset, props to you for being an expert communicator and helping to motivate a debate and discussion that I think really contributed to the science self-correcting. It's a long story, and if the most exciting thing to talk about is an obscure climate scenario, we must really be nerds. But the short story is, and I'll make it as short as possible, that to run a physical science model of the Earth system and project how the climate's going to change in the future, you don't start with physics. You start with projections of socioeconomics. How many people are going to be on the planet? How big is our economy? How are we going to power that economy? And what technologies are we going to use in that economy? Those tell us, among other things, how much carbon dioxide we're going to emit. And carbon dioxide is a primary forcing for climate change.
And methane and the other greenhouse gases.
That's right.
Yeah.
And so those are inputs into the models, and just simply more carbon dioxide, more climate change. And so historically, the climate community used a scenario. Most recent incarnation was either RCP 8.5 or SSP 8.5, where the designation 8.5 refers to radiative forcing.
So we have a rule here, which I can't break, which is about acronyms. So that is RCP is the
representative concentration pathway.
And it's important. Concentration refers to concentrations of CO2 in the atmosphere, not to anything else, not to a temperature.
That's right.
Not to, and it's a pathway which actually means it's keyed to 2100.
Right.
It's not just something that might happen at some point. And that's important. We'll come back to that, right?
It's a path from today or 2000 to 2100.
Okay, so there's a bunch of them. There's a 1.5 degree compatible one, which is RCP 1.6, I think. 1.9, and then at the other end you've got this extreme one, RCP 8.5, and now the modern one. It's now called SSP 5.85. The 8.5 or 8.5 is still the forcing, the watts per square meter in 2100, but the SSP is now, because they do these things called shared socioeconomic pathways. And anybody who's listening who's thinking they are in Wonksville, it's just because of the acronym rule that I say that. But it is essentially a view of the way the world's economy evolves. And if you want more information, Google is great for that. And so is ChatGPT, Claude, or Perplexity. Let's move on.
Yeah, well, let me just say, one of the challenges on this issue is its inscrutability and the fact that it's so difficult to understand because there's so much jargon, so much technical details. In my talks I give, I start out with a slide that has literally 50 acronyms. We could spend the entire show going through acronyms. And so I think it's well described that these are just shorthand for how the climate community, everyone from economists to demographers all the way up to physical science modelers, think about the path from today to 2100 and beyond.
Okay, so why have you and I spent such a big chunk of our time in the last, frankly, nearly a decade in my case, since about 2018, doing this deep dive and becoming so strident about RCP 8.5 or SSP 8.5?
Yeah. So again, the short story is the climate science community got off track literally about 20 years ago. And there's a lot of reasons for that. I've written papers. There's nothing sinister about it, but it's how science works, where that most extreme scenario, the 8.5 scenario, became characterized as where we're headed. The name was given to it business as usual. And if it wasn't called that, it was treated that way. And so studies were published, university press releases were put out, New York Times articles were written, Guardian articles were written, all focused on this particular view of the future. And as anyone who works with scenarios knows, they're not predictions of the future. And certainly we wouldn't pick one. But the community settled onto this one, which painted a very extreme, and as we know now, implausible picture of our climate future.
Okay, and so the short version of why we should care about it is, anybody who's listening to this who has never heard of RCP 8.5, almost all of the press coverage of the future in a climate change world is keyed to 8.5. Even if the journalist writing it didn't know that, and many of them don't, and certainly a lot of the audience, a lot of the general public don't know. But the fact is the science that they're reading, they say, oh, I must write this article, and the editor says yes, that science is probably keyed to 8.5. The second thing you said is, and it's implausible. And the thing in the news is that the academics responsible for choosing the scenarios that the IPCC, the Intergovernmental Panel on Climate Change, uses, that academic group, and there's about 50 of them, that have published saying, yes, it is implausible. They didn't quite say Michael was right, but you know, that I'm sure that line just got edited out right at the end of the peer review process. But they've said it's implausible, right?
Yeah. And so, I mean, and just to extend what you said, it's not just the media. It's in policy. It's in regulation. It's in tens of thousands of scientific peer-reviewed articles. It's in the assessments of the U.S. government, the British government, the Dutch government, the Australian government, on and on and on. It is foundational to banking and regulation and stress testing. The scenario has come to dominate the entire ecosystem of climate discussions.
So I've just written something on sea level rise and what we can expect. And I used the example of the time when I was on the board of Transport for London. And if you believe RCP 8.5 is a plausible outcome, then essentially we have to start, increasing London's flood protection, the tidal barrier. We need to start planning, spending money, acquiring land and so on pretty much right now. If it is implausible, we can use that money for something else. It's a real world example of potential misallocation of resources based on this arcane scenario that most people have never heard about.
This is why plausibility is so very important. We should have debates. What is the worst case scenario? How bad could it get? Where should we draw that fuzzy line between what we think is possible, what is plausible, probable, and what we can leave off the table? And, take an asteroid impact. It's certainly plausible. We could get hit by an asteroid. We should spend some money. It's probably not plausible we're going to get hit this week.
So my favorite thing to worry about is actually the Carrington event, the solar storm that happened in the 19th century. It was so bad that telegraph officers could sell telegrams without power supplies, and there were sparks shooting out and so on. It would be really bad. But that's not. Nobody in climate worries about that because it doesn't fit the narratives.
Right. Well, I mean, so this is one where yes, we should have extreme low probability scenarios, but they have to mean something. You just can't pick a number out of the air and say, okay, well, 8.5, that's a big number. Let's use that. Why not 10.5 or 27.3?
And in fact, if you go back to the paper in which the RCPs were launched, which is by a researcher called Detlef van Vuren, who's actually the lead author on the paper that now says it's implausible, the first line of the abstract of the first paper that launched them said that they're meant to be plausible. It actually uses the word plausible.
Right. Yeah, the IPCC in its governing documents, in its definition of scenarios, says that they have to be plausible representations of the future.
Okay, so RCP 8.5, this foundational scenario on which so much science, I just looked in Google Scholar, 105,000 papers now use it, including, by the way, about just under 3,000 published this year. It is now implausible. And so I'm doing laps around the garden. It took 8 years, but they finally saw sense. You're probably doing the same. In fact, more, because you've done more work on this with Justin Ritchie. Say hello. Great researcher. But it's not, they didn't cave in completely because they said it's now implausible, as though it ever was plausible. Was it ever plausible?
So you mentioned Justin Ritchie, University of British Columbia, who's a longtime colleague of mine. All credit to Justin. He did his PhD on this topic well over a decade ago. And what he explored, and so the reason that RCP 8.5 and the similar are implausible is they project futures that are dominated by coal energy.
And when you say dominated, we're talking about 7 times more. I mean, there's various ways. The C, the concentration in 2100, it goes as high as in the SSP, the modern version,
right.
It goes as high as 1,100 parts per million of CO2.
Right.
When yes, it's terrible.
Right.
We're at 430 now, and we were at 280 before the Industrial Revolution. But you have to get to 1,100,
right.
And if you do it with coal, you actually need 7 times. You need to be burning 7 times the amount of coal that we're currently burning. And coal burn, it's bounced around a bit. It goes up
right.
when the gas price goes up, for instance,
right.
because of the situation in the Gulf or the
right.
Russian invasion of Ukraine. But we are not going to see 7 times the coal burn. And what was it that Justin Ritchie and Hadi Dowlatabadi discovered?
Yeah. So to put that in more apprehensible numbers that people can understand, an increase of 7 to 9 times the coal production is something like 30,000 to 40,000 new coal plants equivalent to be built in the next 70 or 80 years. It's an enormous number. The scenarios are built on our understandings of the world, and what Justin and Hadi discovered was that there is this theory called learning by doing. The energy systems that dominate our mix will only become more dominant because they will become cheaper and we'll get better at it and they'll expand.
So this is positive feedback on costs, which of course we've seen in solar and batteries
right.
and wind and
right.
EVs and so on,
right.
very, very markedly, less so in nuclear.
And that's one of the problems with the theory, is that not everything else stays equal. And that theory underpinned not just RCP 8.5, but all of the RCPs, all of the SSPs. In fact, if you look at the entire spaghetti diagram of future coal consumption under the RCPs, the SSPs, and the entire generation of scenarios, they all have coal increasing to 2100, some by a small amount, some by a massive amount. The RCP 8.5 was way at the top. And the idea was, we're going to get rid of natural gas. We're going to get rid of nuclear. We're going to get rid of petroleum and have coal to liquids. And the idea was everything was going to become coal.
So this was a conversation I had with Nico Bauer from the Potsdam Institute on a podcast. This was Chris Nelder's podcast back in 2019 or something like, around then. And he was explaining that basically we run out of oil, we run out of gas, but we're all rich, so we insist on transport, and therefore it has to be coal. And I was like, well, haven't you heard of EVs? Haven't you heard of electrification? And it wasn't in the peer-reviewed literature. So the answer was no.
Right. So I mean, so this theory, it was a single point of failure across thousands of different scenarios. And it turns out there's still vestiges of that theory in the current generation of scenarios.
But what Justin Ritchie and Hadi Dowlatabadi found was that there kind of isn't enough coal that's recoverable. So even if you built all those power stations on what would presumably be flooded coastal plains, because you're in RCP 8.5, there wouldn't be enough coal to power them. So not plausible.
Yeah, and there's multiple reasons. And economics, as you mentioned, of alternatives is another reason.
So when I go back and I have I can kind of justify, because RCP 8.5 was based on earlier scenarios. There was the scenarios that were around the turn of the century and in the first 5 years of this century, when China was growing like crazy, and the coal use was going up 10% per year. And in a way, there were these scenarios that said, well, let's have a look at what happens if that continues. So they didn't really test for plausibility. But then when it became an official IPCC sanctioned scenario, they really should have tested for plausibility. What does a plausibility test? Because that's one of the things you're now calling for. There needs to be an actual. You can't just say these scenarios need to be plausible, but without an academic process to say, what does that mean? What does a plausibility test look like in your view?
So let me give you an analogy. So let's take one of my sons, and let's say I measure his height from age 9 to age 15. And I say, based on that trend, it looks like he's going to be 10 meters tall by the time he's 25 years old. That's not plausible because we know something about the dynamics of growth and humans, and we have other experience. And so yes, you're right that in the big China build out and expansion of coal, there's a graph that shows it's 2014 that the world emissions were bang on RCP 8.5, and the worst thing you can do as a scholar is take a line and draw it through 10 years of data and extend it to the end of the century, which is pretty much what was done. You have to go on and look at the underlying dynamics. And let me just say, as Václav Smil has well documented, energy system projections is a graveyard full of bad predictions. We're not very good at it. That's why we use scenarios. And so not only was it wrong, but we relied on a single point of failure. That's the big problem.
Some of us would say that Václav Smil is speaking for himself because there are those of us who've not predicted exactly what's happening now, but have come a lot closer than Václav Smil.
Yeah. It's no one's perfect in that regard for sure. But few people know, and this is again part of the mistake that was made in the early days. There was 3 of the RCPs that were supposed to be baseline scenarios, not just 8.5, 6.0, and 4.5. At some point, those other 2 dropped off, and RCP 8.5 became this is where we're headed, and that was the crucial error.
So what is now going to happen? What does this mean? What is everybody going to do? Because 105,000 papers, you've got another assessment report coming up. The IPCC in 2028 or 2029 is going to publish again another summary for policymakers.
Right.
What are they going to do?
So what's going to happen next is crucially important, and it I can't overemphasize. It's a big deal. There is a new high scenario. It's called high, and the integrated assessment models haven't been run, or the climate models, but we do know it's something like a radiative forcing of 6.7. So it's much less than the 8.5, and it's even less than the 7.0.
Okay, and that's high as in HIGH,
right.
High, not high as in hello. Hello, we got to start again. This is high as in a high scenario. There is high, there's medium, there's low and very low, I think. Is that right?
And then there's a couple weird permutations where emissions drop really quickly. I understand those will be low priority.
There's a science community that is going to need to figure out what to do with 105,000 papers and the future of climate research. But there's also the policy community that is going to have to do something, respond in some way to the fact that much of what the tools they are using is built on a scenario that has now, for whatever reason, been declared implausible.
So policymakers need to understand. So if you're building, let's say, and this is a real world case, you're preparing the San Francisco airport. If anyone has ever landed there, you're right above the sea level. If you're preparing to adapt that airport for sea level rise going forward, you need to be focused on more plausible scenarios, not the worst case, not the 8.5, not the 8.5 H++, which is 8.5 on steroids.
The same in the network for the greening of the financial system, so the NGFS, which Mark Carney kind of put together.
Right.
Okay, fine. But as a policymaker, what do you do tomorrow?
Well, I don't think that there's any particular mitigation or adaptation policy that is immediately dependent on the scenario change. The reality is, and you and I have discussed this, that the pace of mitigation, emissions reductions is going to be much more a function of economics, technology, public opinion, and the climate part will get carried along. In the United States, the big discussion is energy affordability. And I think that's perfectly compatible with an aggressive mitigation agenda. And so I don't think that the climate science in this case is going to lead just like it didn't before.
So I have to say that a lot of people, after I wrote my pragmatic climate reset piece last year, said, oh, Michael, does that mean that you now think we should just target 2 degrees instead of 1.5 degrees? And I said, no, I actually think we should target growing the clean stuff as fast as possible. If we can grow the clean faster than the growth in energy demand in the world, we'll be okay. And you said something very wise in when you came on the show in 2022, which is that this is multi-decadal. And so we should stop searching for the quick target or the quick action. And we just need to be, we need sustained multi-decadal effort. And that's kind of what I focus on.
Yeah. And, it's another show. We'll have to do that sometime. But the whole idea of temperature targets as a policy object doesn't make much sense. There's no knob in the policy control room where you can dial it to 1.7 or 2 or 1.5. It's not how it works.
Cleaning Up is proud to be supported by its leadership circle. The members are Actis, Alcazar Energy, Arup, Copenhagen Infrastructure Partners, Signum Capital, Davidson Kempner, Ecopragma Capital, EDP, Euroelectric, the Gilardini Foundation, KKR, Mitsubishi Heavy Industries, National Grid, Octopus Energy, Quadrature Climate Foundation, Schneider Electric, SDCL, and Wärtsilä. For more information on the Leadership Circle, please visit cleaningup.live. To keep up with all that's going on in the Cleaning Up universe, make sure you subscribe to our newsletter. Written and edited by my longtime New Energy Finance and Bloomberg NEF colleague, Angus McCrone, it comes out every second Monday. Angus provides the latest on the episodes we're recording, the events we're hosting, stories we're watching, and what Bryony Worthington and I are up to. To sign up for the Cleaning Up newsletter, visit cleaningup.live. One of the things that I've noticed, and there's people like Richard Betts have been doing this, is to kind of sidestep the whole discussion about RCP 8.5. They've been saying, well, I'll run scenarios at 2 degrees of warming by 2100, because frankly, anything less than that is not really plausible.
Right.
And 4 degrees. So he's made up his own high, which is 4 degrees. Where does the new kind of officially sanctioned, the officially proposed Van Vuren et al. 2026 high, that's 6.7, effectively going to take us to 6.7 watts per square meter of forcing. That's what you're saying. It's equivalent to RCP 6.7. What temperature is that going to get us to if it's in that scenario?
Yeah. So I took the data that associated with the new paper they put out, and I replicated the methodology and ran the new emissions profile of the high, medium, and low through a climate emulator. These are simplified climate models, so to speak. And I came up, it depends which one you use, FAIR or MAGIC, 3 to 3.2. I saw in the media, Detlef Van Buren said 3.5. It's way less than the 4.7 to 5.4 of the 8.5 scenarios.
So the 4.7 to 5.4, those are degrees centigrade of warming. So
by
we
2100.
We were in a world until literally last month where everybody was saying, whatever we do in the policy world has to be robust to a 4 to 5 degree centigrade warming. So you've got people like Richard Betts saying, well, we don't use the scenario, but we retain the 4, maybe not the 5, but the 4 degrees of warming. And what you're saying is now the high scenario only gets you to, Van Vuren says 3.5, but you think it's closer to 3.2.
Based on their methods, yeah.
And how plausible is 6.7? I mean, again, I asked you the question, actually, we should get back to, how would you test? What does 6.7 involve, and is it plausible? How would you test that?
Yeah, so here's another major flaw in the process. These numbers are generated before anyone tests for plausibility. And this was a mistake made 20 years ago when they separated out. Justin Ritchie calls it a plausibility vacuum. They say, this is what we want to run our models on. You integrated assessment modelers, you go figure out what it would have taken to get there.
But in the paper that's just been published that says, okay, RCP 8.5 is no longer plausible, even though actually you and I would say that it never was. Does that paper include the new high scenario? If so, how does it justify it?
So the new high scenario, I mean, I'll give them credit. They say it's not a baseline scenario. This is not where we think we're headed. To get to the high scenario, we would have to choose to get there. So it's an exploratory scenario of what they call walk back or no longer trying to reduce emissions, but actively trying to increase emissions.
But that's very dangerous because Jim Skee, who's the chair of the IPCC, so actually in charge of all of this, he came on Cleaning Up. That would have been in 2021, I'm going to say. And I asked him, I challenged him on RCP 8.5, and he said that I'm going to be very careful with my choice of words. It is physically possible to be on it, but you would need to essentially, I can't remember the exact words he used, but demolish all the solar plants and all the wind and all the progress and all the changes that have been made, all the clean energy that we've got. You'd have to actively go out and do that, right? So the same as you're saying that you'd need to do to get now to high, except that still, even though he said that, people continue to use RCP 8.5 as business as usual. So won't high just become business as usual in most people's minds?
There is an enormous risk that it'll just be treated as a reference scenario. I mean, when RCP 8.5 was put out, I have a slide in my talks that had Richard Moss, who was one of the creators, who said, don't use this as a reference scenario. And of course, everyone did.
And Johan Rockström came on my show around the same time and said he never uses 8.5. And in fact, even famous papers like his Hothouse Earth paper uses RCP 4.5.
Right.
So if I had to put you on the spot and say, what would you use as high? If you had to just choose a forcing number in 2100 for high, in other words, you just can't see plausibly anything worse than this, what number would you use?
So the first thing I would do, and I mean, what I wouldn't do is just pull a number out of my rear end. I would say, let's do the plausibility assessment. One of the things that has not been factored into the scenarios, for example, are changing demographic projections. The current high scenario is based on an assumption of 14 billion people in 2100. That's not plausible. And so we would have to go back, and this is why it takes...
So the high that is being now suggested, promoted, put forward for endorsement by the IPCC has a population of 14 billion in 2100.
Yes, it's based on SSP3,
But there's I'm not hugely familiar with the population literature in all its glory, but I do know that we've got plummeting fertility around the world, with some exceptions in African countries and some other parts of the world. But I don't think there's anybody who thinks it's going to be 14 billion.
No, you're right. And there's not. And so that's an implausible assumption. If you simply adjust that, and this is not how scenarios work, but if you do a back of the envelope adjustment for where demographers think the world is actually headed, high becomes a lot more like the medium scenario. So to assess plausibility is not kind of a quick thing you do. You have to do the work.
And so from what I'm hearing is it may be that 4.5 is actually what should be high, but we don't know if we don't do the work. And one of the reasons, by the way, I think that we haven't done the work on that range. This is one of the tragedies of the RCP 8.5, the lost decade. You can excuse the first decade, but the second decade from sort of 2017, from Richie Dalatabadi onwards until now, we've got a vacuum of research in the direction that the Earth is actually headed, which brings us to, there'll be people out there screaming at their into their headphones or at their phones saying, tipping points. These buffoons, they're not talking about tipping points. They're missing it. What is your assessment of the current literature, or where are you on tipping points? Are they real? Are they potentially really bad? And how fast could they be?
Yeah. So I can date myself. I was on the first U.S. National Academy of Sciences panel on, at the time, what was called abrupt climate change. That's how we used to talk about what Malcolm Gladwell codified as tipping points. And the idea of abrupt climate change has been around for a long time. And there's I would make a few points. One is that historically, and if you look at long-term, the paleo record, the climate can move quickly with or without human influences. And so being prepared for abrupt changes in climate is something like waiting for an asteroid that we should be paying attention to, which is a good justification for very effective monitoring systems of the Earth system.
When you say they can move quickly without human interference, and obviously there is the famous is it an asteroid or a meteorite? I don't know the difference, but that terminated the dinosaurs. Whether that is actually how it happened or not, that one is obviously very abrupt. But other than that, the temperatures have fluctuated very widely, and you can say quickly and obviously clearly in the paleo record without human influence. How quickly was quick in the past? So
in that study that I participated in, and again, I don't do research on short-term climate change, but decadal was the time frame. That's substantial disruptions on decadal timescales for reasons that are somewhat appreciated but not fully understood, and not predictable is key.
But this would be things like the Great Lakes in North America suddenly emptying into the Atlantic and the
I don't know that it's
overturning
yeah,
current
I don't know that
stopping.
it's so abrupt as that. I think it's more like a sustained and large El Nino event or a shift in ocean currents. Something of that magnitude. The idea behind tipping points with human forcing is that we make those sorts of things more likely to occur in unquantifiable ways, but it increases the risk.
And so, in answer to one or two of my questions, they are real and you are concerned.
Absolutely. And I mean, this is for me another background reason why aggressive mitigation makes sense, because the less we poke the system, it doesn't eliminate the risk of abrupt changes in climate, but it certainly reduces them. And again, you're not going to be able to put a dollar value on it. You're not going to be able to predict when it's going to happen. This is one of those things where it's one of those benefits we get from aggressive mitigation is we're just provoking the system a little bit less.
Okay, and then when you look at the list of them, and I talked about this with Johan Rockström, only it was a few years ago. I couldn't see any that would really impact. And Johan talked about the difference between the commitment time, the time that we in our short lives have to actually stop, the processes, irreversible processes happening, and then the impact time when an ice sheet can melt by so much that it actually starts to obliterate our cities. And I couldn't see anything that could happen in that decadal time frame. So Amazon flipping into a tundra, it's like, yes, absolutely it could. It has done before, but that takes hundreds of years, possibly a millennium. And then the ice sheets, definitely. I mean, we've just had the world's oldest iceberg has just finished melting. It's 1,000 gigatons. It's called A23A. It took 40 years for one iceberg to melt. That's 1,000 gigatons. Greenland and the Antarctica, they're millions of gigatons. And I have people, no doubt we'll have the comments filled with people who think that they can melt in the next few decades and obliterate our cities. David King, the former science advisor to Tony Blair, Sir David King might well be amongst them. What do you think to that?
Yeah, so I mean, this is one where we don't have to look too far into the past to see that there have been some abrupt changes. And whether they qualify under Rockström's, planetary boundaries framework or not, who knows? But look at the 1870s. The 1870s were enormously disruptive across planet Earth in terms of one of the largest El Nino events ever recorded, 1877, 1878. There are estimates that something like 4% of global population perished, largely due to drought that was extended around the world. Take a look at the 1970s. In the 1970s, there were failed harvests in the Soviet Union and elsewhere because of dramatic shifts in the climate system.
But wait. Let me stop you. Yeah. Was that climate or was that weather?
So, I mean, this gets to the definition. So the IPCC defines climate as the statistics of weather on many decade timescale. So there's another more general definition that says climate refers to processes like El Nino or the Pacific Decadal Oscillation. These are the underlying climate factors. So one thing for people to understand is that climate is not a cause. Climate is not a cause of anything. El Nino, ocean temperatures, cause weather. But if there are shifts in modes of variability in the climate system, they can lead to profound shifts in weather around the world on yearly, decadal, seasonal timescales.
So let me come back to the question of, in a sense, well, let's link it back because that's how we do it to these scenarios. Is there anything in the tipping point literature that could make up for the fact that we are not on the 8.5 watts per square meter or the concentrations of CO2 that would lead to that forcing pathway by 2100? By 2100, because that's important. So there are lots of bad things that can happen over longer time frames. And we've talked about William Nordhaus saying that the optimum scenario is one that leads to beyond 3.5 degrees next century. So could really bad things happen over time? Absolutely. The question is, could we be on that particular pathway by 2100? What's your sense?
Yeah. So, I mean, I think one thing that we, just as a matter of logic, that if we're on a 4.5 or 3.4 trajectory rather than 8.5. In climate models, at least, the chances of reaching a tipping point are reduced than they would be otherwise in those more severe. They don't go away. In the real world, I'm not confident we have enough knowledge as to where tipping points might lie. And so again, this is another background reason, I think a strong one, for why we want to disturb the energy balance of the Earth system as little as possible.
But it's also why we want to research where we're really headed.
Right.
Because the analogy that I've used is if we're boiling a pan of milk and we're going to put it on the stove at, I nearly said gas setting, but electric hob setting 5.
Yeah.
And the only knowledge that we have about pans of milk boiling over was gained by putting a pan of milk on the stove on hob setting, ceramic hob setting 10.
Yeah.
We can't take any data from 10 and apply it to the 5 scenario because it's just non-linear. We've learned nothing until we research the sort of RCP 4.5, 3.6, 2.9, until we really put our resources into understanding tipping points in those trajectories, we actually don't know very much.
Right. Well, and this is where, some of my colleagues I'll depart from, because I don't think that the answers to those sort of questions have much relevance for how fast we ought to be mitigating. I think that the challenge of mitigation is insensitive to those sorts of questions. And I know, the planetary boundaries folks and the extreme scenario folks have this idea that the politics of climate change can be hotted up by having more extreme scenarios. Oh, fear of tipping points. Oh, we're exceeding the planetary boundaries. I just don't think that moves anyone in the real world. And so, we should study as much as possible, but we also have to realize we're going to have some fundamental ignorance as to how the future is going to play out.
My inbox is going to fill up with people talking about the AMOC, the Atlantic Meridional Overturning Current, and how there's this body of science, and the IPCC has not yet reviewed it, but is this very convincing body of science saying that it's going to shut down. And of course, when you go into the science, you find that what it actually says is it's going to slow down, and there's good consensus on that, but it's going to slow down by 30, 40%, 50% by the end of the century, which means it's not going to collapse, even in that body of science, until presumably next century or the one after. I don't think we walk away from our responsibility to act, but I do think that using that and particularly exaggerating, saying the AMOC could shut down within a decade or two, that is not going to motivate action. If we've learned anything in the last 22 years I've been doing this, and longer in fact that you've been doing it, surely we should know that scaring people about future impacts and then not actually even having it backed up in the science doesn't work.
There is this theory of change that we get action on energy systems by scaring people to death over climate change or tipping points. And it not only does it not work, it can actually backfire in the sense that people lose faith in science. The RCP 8.5 story is ultimately a story of self-correction in science, which is what science does really well. Yes, it took too long, and there are still people who are pushing back against that. But when science self-corrects, it builds confidence among people. I have a lot of scientists who have said to me, well, if we admit that we were going down the wrong path, people aren't going to trust us anymore. No. If you don't admit it, they're not going to trust you because it's obvious now that those scenarios are implausible.
And I have a lot of sympathy for activists.
Yeah.
I think in a sense in the ecosystem that actually gets societal change, and you work on the policy and policymaker interface, but of course they interact with society as a whole, which has got all these different constituent parts. So if activists, Greta Thunberg saying, be afraid, and the fact that she didn't know that RCP 8.5 wasn't implausible and so on, that's not her job to know. Although when she says follow the science and the science doesn't say what she thinks it says, that's kind of bad. But I don't worry about the activists. I have a bit more blame for or for the general public, no blame there. I have a bit more blame for journalists, particularly specialist journalists. But there's a group of people that I really think have behaved discreditably, I'm going to say it, which is some of the scientists who have known about this, you could say, since Richie Dowlatabadi 2017. There's it's a letter to Nature, or is it a letter or an opinion? I'm not sure what it, but it's the business as usual scenario is misleading, headline in Nature, and they have spent years trying to defend the indefensible and are still doing so to this day. And those people, I have to say, I mean, I'm going to give you an example, which as somebody you know, who wrote to me when I think I sent out a link to your paper on the misuse of scenarios, your paper with Justin Ritchie. I tweeted it or put it out on LinkedIn and Blue Sky because I think it's an important contribution. And he wrote to me, and I'm going to quote what he wrote. I'm a big fan of your energy and hydrogen work, as you know, but Roger Pielke Jr. is one of the most discredited and debunked, invert air quotes, researchers in climate. By endorsing him, you are saddling yourself with 15 years of dubious science and vicious attacks on anybody who questions him. And then a bit later, he says, he is a very bad researcher and terrible human being.
Well, you know, if I had $1 for every time we were called deniers and climate skeptics when we first started doing the scenarios work, you know, I could probably fund the energy transition myself. I mean, I guess the joke's on him now because, you know, our work has stood the test of time. And that's, you know, you expect debate in science, and when it becomes perceived as inconvenient to someone's politics, that's the problem.
That email is not science. That's an unsolicited email to me. I'm not in the science debate, right? I'm not a scientist. I've got a few published papers because I'm a visiting professor at Imperial, but I wouldn't call myself a scientist. I'm an energy expert and a commentator and an analyst. Unsolicited email trying to warn me off from engaging with you, I consider that complete. I'm sorry, I use the word discreditable. It is unacceptable behavior in my view. I mean, I know you've made errors and you've corrected them, and maybe you've done that a little too slowly and so on. But that was unacceptable. I want to, just before we finish, coming back to your own research, if we can just finish with that. You have a long history of research into hurricanes, their frequency, their strength, their impact. When we last spoke, when you came on the show, we reviewed, there were a number of touch points from the first report. I think your first research was it 1995 or something? I mean, really showing our age. And then you've updated it periodically. Have you updated it in the last few years? And what does that say? Yeah,
so we have Jessica Wenkel, who's a professor at North Carolina, Wilmington, one of my former PhD students a million years ago. She and I have an updated normalization study on U.S. hurricanes. And the numbers keep going up for the possible damages. We're up to the 1926 hurricane could be more than $400 billion in total damage in 2026 dollars. So, and you know, the driver is obviously more people, more wealth, more property in harm's way.
So, because your innovation back then was to normalize. So you have these insurance companies saying hurricanes are getting worse and worse and worse. They're getting worse and worse in the monetary cost, but you normalized for that. And said that actually, no, all of that trend relates to how much stuff we put in.
We just simply asked if you took the storms of the past with today's population and wealth, what would we expect damages to be? That's, of course, what catastrophe modelers do. We did it empirically using a normalization routine.
Did you triangulate against the geophysical record? Because there's one thing to say, well, we normalized it, but you know, there's also buildings are being built better and so on. The building codes have improved, so maybe it's just an artifact of that. Did you also dive into the geophysical record?
So one of the ways that we evaluate the results of our normalization is we take each decade, and obviously damage is caused by storms that make landfall where there's property. And our argument is that trends in a normalization should match trends in both the intensity and frequency of storms. And from every decade, from 1900, 1910, 1920, 1930, and so on, all the way up to present, we evaluate trends in hurricanes, the geophysical dynamics of the storms, against the economic trends, and they match up.
Except that I hear there's a Stefan Ramstorff, also very vocal about the AMOC. He says that storms are getting, and it's not just hurricanes, but tropical storms are getting more severe. They're gathering strength faster, and they're moving north. Is that Is that
So
right?
let's take that apart. So where there is no controversy is in the U.S. landfall record. You look at the IPCC, you look at NOAA, Geophysical Fluid Dynamics Lab.
NOAA?
National Oceanic and Atmospheric Administration in the
Sorry,
U.S.
that was an acronym.
Yep, a fantastic agency. They have an updated page. There is no trend in either the frequency of storms hitting the U.S. or in their intensity. So that matches up with the normalization. There are some great hypotheses out there about storms tracking further north, more rainfall coming out of storms, faster intensification, faster forward movement, slower forward movement. Those are hypotheses. And to date, the IPCC has not given any of them more than medium confidence.
But there is one that I think it's not maybe been covered by the IPCC, which is the ratio between intense tropical storms and less intense tropical storms has tilted statistically significantly in favor of intense. So a bigger proportion of storms are intense.
So there's two ways to explain that. One is if you start your data in 1970, yes, you will see that. If you start your data in 1950, you won't see that. The other thing is the trend since 1970 is not because there's more intense storm. It's because there's less overall storms. And so people get a little bit funny when they talk about the proportion has increased. The number of intense storms hasn't increased.
I'll be honest. I think that I that's the answer I was expecting.
Yeah.
That if the denominator gets smaller, then the ratio goes up. But
Right.
it doesn't mean the world is a worse place
Right.
or a more dangerous place. And I think it's a good example of clutching at straws,
Right.
because everybody expects there to be more tropical storms because there's more heat in the oceans, and that's one of the big drivers. But it is hard to predict exactly when that.
Climate change is real and serious, and we should be concerned about it. In all honesty, tropical cyclones, hurricanes are probably one of the worst places to look for it. There's only 60 to 80 such storms every year around the planet. There's enormous variability. If you look at precipitation or temperature, we have fantastic measurements all over the world every single minute of every day. You're going to see much stronger statistics emerge than looking at the small number of extreme hurricanes.
Roger, we're going to have to draw a line there. I think we've beaten our audience around the head with enough scenarios, enough technicalities. It's been an absolute fantastic wonk fest. I've really enjoyed it. I hope the audience has been able to keep up. But thank you so much for taking time out during this trip through London to speak with me.
Thanks for having me. It was fun.
So that was Professor Roger Pielke Jr., Senior Fellow at the American Enterprise Institute and author of the Honest Broker Substack. As always, we'll put links in the show notes to resources we discussed that you might find useful. So that's Roger's first appearance on Cleaning Up, episode 93, Professor Johan Rockström's episode number 49, and Jim Ski's episode number 36. Also, we'll link to the two papers with Detlef van Vuren as lead author, one from 2011 that launched the RCPs and stated that scenarios needed to be plausible, and the one from April 2026 in which RCP 8.5 was finally declared implausible. Also, my recent Substacks on RCP 8.5 and on sea level rise. And with that, I want to thank our producer, Oscar Boyd, video editor, Jamie Oliver, head of operations, Kendall Smith, the team behind the scenes, and the leadership circle, without whom none of this would be possible, as well as you, the audience, for spending time with us today. Please join us at this time next week for another episode of Cleaning Up. Cleaning Up is proud to be supported by its leadership circle. The members are Actis, Alcazar Energy, Arup, Copenhagen Infrastructure Partners, Signum Capital, Davidson Kempner, Ecopragma Capital, EDP, Euroelectric, the Gilardini Foundation, KKR, Mitsubishi Heavy Industries, National Grid, Octopus Energy, Quadrature Climate Foundation, Schneider Electric, SDCL, and Wärtsilä. For more information on the Leadership Circle, please visit cleaningup.live. If you're enjoying this episode, please hit like, leave a comment, and also recommend it to friends, family, colleagues, and absolutely everyone. To browse our archive of around 250 past episodes and to subscribe to our free newsletter, visit cleaningup.live.